Alright, today I'm going to start to talk about differentials. In all honesty, I think what will be the easiest thing for me to do is go ahead and start a problem, and then I'll describe to you what differentials are a little bit further. So in this first problem, what I'm going to do is I'm going to find the equation of the tangent line to the graph of f at the indicated point. And then I'm going to use this linear approximation to complete the table, which is what we're doing with differentials. We're using a linear line or a linear equation to approximate what the actual value is on the function itself. So what I'm going to do is I'm going to actually find this derivative because I need it. This is actually 6x to the negative second. So my first derivative is negative 12 x to the negative third. So I'll rewrite that as negative 12 over x cubed. This is going to let me be able to find that tangent line to the curve. So my tangent line to the curve will be y equals, or let me change that a bit. Let's put it in point slope form. Y minus 3/2 equals, I'll go back and fill my slope in a minute, x minus 2. The slope is figured out by plugging in my 2 right here. The slope at 2 will be negative 12/8. Negative 12/8 reduces to be negative 3/2. I don't really like the way this is written. I'm going to have it as a y equals equation, so I'm going to go ahead and say y minus 3/2 equals negative 3/2 x plus, that would be 3. And then I'm going to add 3/2 to both sides. When I add 3/2 to both sides, I end up with negative 3/2 x plus 4 1/2, which would be 9/2. Now, at this point in time, I would use a calculator just to save some time, because what we're going to be doing is we're going to be plugging in 1.9 to the function value, and we're going to plug in 1.9 into the tangent line. And what we're going to do is we're going to show how these are very close to each other. So I will quick bring up a calculator. I'll just bring up a small calculator. I wouldn't recommend using the small calculator. But what we're going to do is I'm going to go ahead and put in 1.9 in for my function value. So I would say 6 divided by 1.9 squared, or 1.9 times 1.9, is equal to 1.662. So I get 1.6620 in this case. Now I'm going to use the tangent line to the curve. The tangent line to the curve is right here. And I'm going to go ahead and plug in 1.9 in for there. So I have a negative 1.5 negative 1.5 times 1.9 equals, and then I'm going to add 4.5 to it for a total of 1.65. Notice how the tangent line to the curve was very, very close to the actual height of the function, and that's what we're really talking about in differentials, and I will get into that in the next video. Let's go ahead and continue this and show how 1.99 also is going to be very close. So when I plug in 1.99 in for here, I have 6 divided by 1.99 times 1.99. That gives me the answer of 1.5151. And then if I take that same value, 1.99, and plug it in for the tangent line, I'll let you guys do that on your own because I'm running out of video time. But you will get 1.515. Again, very, very close. We'll finish this up on the next video.